Welcome. From all of us at Nexus, we're diving into Chapter 5. In this explainer, we're tackling a concept that's, absolutely foundational for anyone in computer science, virtualization, and how it really supports distributed computing.
So, to really get why virtualization is such a game changer, you first have to understand the problem it's trying to solve. And that problem is data. So, much data. Today's organizations are practically drowning in it. It's coming from everywhere: databases, social media, sensors, you name it. Trying to handle that flood with old-school methods, it's like trying to drink from a fire hose.
So that leads to the big question, right? With all this data in all these different formats, how on earth do you build systems to actually manage it all in a way that makes sense? Well, the answer starts with a surprisingly elegant idea.
And that solution is virtualization. It's a technology that completely rewrites the rules between your software and your hardware. Instead of being stuck one-to-one, virtualization lets us take these rigid physical machines and slice them up into flexible, logical resources.
Okay, so what are we actually talking about here? Well, at its heart, server virtualization is all about taking one big, powerful physical server and using software to partition it into multiple, totally isolated virtual servers. Think of it like this. You've got a giant empty warehouse, and you put up walls to create a bunch of independent little shops inside. Each one of those virtual servers acts like its own complete computer, running its own operating system and its own apps.
Now, the magic behind all of this is a clever bit of software called a hypervisor. This is a super thin, efficient layer that sits right between the actual hardware and all those operating systems. Its job? To be the ultimate traffic cop. It juggles all the requests from each virtual machine, making sure everyone gets a fair slice of the CPU, the memory, and the storage, all while keeping them completely walled off from each other.
Okay, so that's the high-level idea. But how does this actually work? Let's pop the hood and see how one machine really does become many.
All right, so the process is pretty straightforward. First, you start with just one physical server. Then you install that hypervisor we just talked about. That software then gets to work, carving up the physical hardware, the processor, the RAM, the storage, into these neat, isolated containers we call virtual machines, or VMs. And here's the powerful part. Each VM is a completely blank slate. You can run Windows on one, a totally different flavor of Linux on another, side by side on the exact same piece of hardware. And here's the crazy part. Neither one has any idea the other's even there.
Yeah, let's really zero in on that phrase, a software representation. This is the absolute core of it. A VM isn't some watered-down, limited version of a computer. To the code that's running inside of it, it is a physical machine. It can do everything the real thing can. That illusion is so perfect, and that's what makes this whole thing so incredibly powerful.
Okay, so let's tie this all back to that big data problem we started with. Why is this whole approach the secret weapon for handling these massive data sets? It all boils down to one word: scale. Big data problems are almost always distributed problems. You gotta break them up and spread the work out. And virtualization? It's the perfect tool for managing that huge fleet of processors you need.
And this is exactly why frameworks like MapReduce just absolutely sing in a virtualized environment. I mean, what does MapReduce do? It takes a huge job, maps it out into hundreds of smaller parallel tasks, and then reduces all the results back together. Virtualization gives you the perfect flexible playground to just spin up and manage those hundreds of processing nodes whenever you need them.
So what are the concrete benefits here? Let's break it down. Well, the biggest win for sure is that you turn all your hardware into just one big generic pool of resources. And that directly leads to way higher asset utilization because you're not wasting cycles on machines just sitting there doing nothing. From that pool, you can spin up VMs on the fly for better scale and performance, which means you can handle these crazy dynamic workloads without ever having to physically touch a server. And all of that, of course, just massively cuts down on the management overhead.
And this right here, this shows you just what a massive shift this was. In the old world, a data center was just a collection of rigid, siloed servers. Each one was locked to a single job, and a lot of the time, they were just sitting there, underutilized, so inefficient. But with virtualization, that same hardware becomes this fluid, dynamic pool of power. You can point compute power exactly where you need it, right when you need it, and that just sends your utilization and efficiency straight through the roof.
Okay, so virtualization is all about creating a layer of abstraction over the physical hardware to get more flexibility. But if you're a computer science student, your brain should immediately be asking, what's next? Can we take this abstraction idea even further?
And that's really the core takeaway from this chapter. Virtualization is the foundation. It's the tech that lets us stop thinking about individual physical boxes and start thinking in terms of these abstract pools of resources, pools of compute, pools of storage, pools of networking, all controlled entirely by software. So I'll leave you with this question to chew on. What happens when you take that incredibly powerful idea, that flexible pool of resources, and you make it available to anyone, anywhere in the world, on demand? That very question? Well, that's the whole idea behind cloud computing. And that's exactly what we're going to tackle when we dive into Chapter 6 in our next explainer. See you then.